as I understand it, several years ago when GMIS got started, the reason that the UN joined and formed a partnership here, it's really to bring in the developing countries and then match them up with the industrialized companies and make sure we're not creating this huge gulf, right? And you talked about the leapfrogging in the previous conversation, but how do we drive the cost of Industry 4.0 as close to zero as we can, right? And this is happening at the same time where we're just 1 year past Glasgow and COP26. And what we saw in COP26 was a call to say that within the next 25 years, 30 years, we're going to get to total carbon net zero. And how we're going to get there creates this mountain that we're not quite sure how to climb. And it's a big data mountain. It's a digitization mountain. And scope 1, scope 2, I think we all have a pretty good handle on that. That's what you're producing in your factory, what you can manage in terms of shipping products. Well, the vast majority of the carbon is happening in scope 3. And scope 3 is a global problem. That's your mining, that's your refining, that's your materials processing. That's all that embedded carbon. So we got a problem. And it's coming real fast. And we've got regulators now that are knocking at the doors and they're saying, yeah, we're going to start to put net zero requirements out there. Here in the US, the SEC this past year said that they're going to start requiring as part of your 10K filing, if you're a publicly traded company, that you have to track your scope 1 and scope 2. Well, now we've got a new problem, right? And we got that problem of how are we going to be able to have all that sensing, all that data collection, all that reporting to be accurate, not running off models. So now we need to start talking about getting close to net zero in terms of carbon, really close to zero cost in terms of implementation. So that's the theme that I want to talk about here, and I want to talk about those tools, those experiences, and then what are some of the potential showstoppers? We talked a lot about security in the last conversation, but I think it's about trust, and we'll talk a little bit about that. So my name is Doug Ramsey. I'm with Axial. We're a firm that focuses on finance for digital transformation for companies all over the world. I don't want to talk a lot about myself. I want you guys to tell the stories because you're the operators. So why don't you give me like 2 minutes. And Rob, why don't you kick us off?
Sure. Great. Hi, everybody. Rob Shaintaler. I'm in charge of sales and professional services at ThinkIQ. We are a enterprise software company, cloud-based, and we provide a Industry 4.0 platform for manufacturing and supply chain. So based out in California. Been at ThinkIQ since February this year, where my startup was acquired. Prior to that, I was founder and CEO of a company called Autology, where we were approaching the Industry 4.0 space with vision as a sensor and developing ways to use a basic camera as a horizontal sensor to create industrial data and do analytics on it, and in part to start lowering that bar, right, of skills and cost required to start digitizing for some of the small and mediums, which has been a lot of our collaboration with Sesame. So anyway, excited to be here today.
So John, you gave a brief introduction before, but you tell us a little bit more about the mission of Sesame and how the different academic organizations, industrial organizations, the value they get out of working with a public-private partnership.
Yeah, so like all of the 16 manufacturing USA institutes, we've been given roughly $140 million in a window of time to spend those funds to advance the state of the art through our specific lens or area of operation. And for us, that's smart manufacturing, as I mentioned before. So we've specifically called out 5 stakeholder sets that are absolutely essential to disrupting how manufacturing systems are deployed and sustained to achieve the overarching objective of creating a more competitive manufacturing environment here in the US, reducing the cost and complexity and time to deploy smart manufacturing systems, and of course, improving our energy productivity for all manufactured goods here in the US. So we've identified the manufacturers, obviously, as at the center of that stakeholder set, the technology providers, systems integrators and consultants, machine builders, and academia. And it's essentially our goal to bring the leading influencers, market makers, thinkers together to create a roadmap and then use the $140 million that we've been given to execute on that roadmap. Strategic investment plan, not to develop the technologies, the education, the knowledge, and then see it deployed, and then refine it, and then make sure that what we're doing actually works and is relevant and pragmatic and meaningful for the marketplace. So that's essentially the model for all of these institutes, but we're, I think, unique in the sense that we're very horizontal. Smart manufacturing works and is essential for your average discrete manufacturer, your Toyotas, Fords, Stellantis, tier 1, 2, 3 suppliers, your hybrid manufacturers like Procter & Gamble and General Mills and ConAgra, and your hardcore continuous process manufacturers like ExxonMobil, the super majors, et cetera, Linde, Praxair. So this is not an industry-centric thing. This is a completely horizontal need and set of strategies and set of solutions that we are working together as an ecosystem to solve. And part of that, and I'll close with this, is just working together to create an environment where not everything is proprietary, where the technologies and the networks and the way we expose data doesn't have to be proprietary. It has been for Industry 3.0 created a bunch of great companies in the automation and information space, but they have built proprietary systems, and it's so difficult for them to learn how to think in ways that are open and support this notion of collaboration and ecosystem. But that's the baseline for where we have to go together as we create a more competitive manufacturing environment.
It's excellent. So Lin Han, you come more from the product and the engineering side. And you brought something that we can all kind of poke around here after we get off stage, which I think is fascinating. But you also come from Hollywood to manufacturing and product, and that's a hell of a story.
Yeah.
So give us a flavor of that journey and how you're pushing into democratization.
All right, so Hyperganic is doing what we call algorithmic engineering. So if you think about it, it's really encoding our knowledge and experience as engineers into algorithms, right? No longer do we have to actually sit in front of a computer to CAD something out, because frankly, if you think about it again, that's how Leonardo da Vinci modeled his water wheel. That's how modern engineers engineer objects, right? Manifestation of imagination onto a piece of canvas, be it paper or computer screen. We want to now capture that, then automate that process, right? And in so doing, we really do not have to start redesigning or reinventing the wheel again, right? What I have here is an algorithmically engineered rocket engine, of course with a cutaway, right? Has anyone heard of a aerospike rocket engine before? All right, fantastic. So it was conceived in the 70s, right? But it never actually took off. Why? Because of a series of engineering challenges. One very important one is, we have a central spike in it, right? It achieves very nice high efficiency, right? Single stage to orbit and stuff like that, but it melts, right? Imagine hot fumes rising through, right? This internal cooling combustion chamber. Without cooling, it's going to melt. So with the advent of additive manufacturing, we are now able to drive designs of internal cooling channels such that the central spike function properly. But guess what? Maybe, the startups these days who are doing aerospike engines take 6 months to a year to design their object and test it, bring it back to the drawing board after feedback, What you see here is only one of an entire class of aerospike engines, because we've parameterized every part of the design, from the cooling channels to the combustion chambers to the injector heads. So once we have that, we can actually see cross-pollination of all these algorithms. For example, the cooling channels can actually be used for capillary designs in bioengineering. So that's cross-pollination that we see every day that is going on in Hyperganic. And the story about the Hollywood part is that our founders, Lynn Kaiser and Michael Gallo, they're actually co-founders of a previous startup called Iridas. And what Iridas did was revolutionized Hollywood. They created the first ever digital playback engine for visual effects films, and it was actually used for the making of the Matrix movies. Soon after, they were acquired by Adobe, and yeah, here we are.
And you've leveraged a lot of that and brought it forward into the generative design world. That's interesting. But so in the spirit of open source and open architecture and democratization, how much does your software cost when somebody logs on to use it for the first time?
Go to high-beginning.com and you can sign up for the platform for free. So education is, in a horizontal implementation, is very key for us. Yeah.
Right.
Can I
go ahead.
pile onto that?
Yeah.
So when Procter & Gamble became a member at SESME, one of the problems that they wanted our help solving was what they called innovation triage. When they look at their manufacturing OT and IT software partners and say, hey, I want to go to that plant and stand up a system and begin innovating and put a pilot together for this quality problem or that maintenance quality or that production constraint over there. It took them 6 months on average, and this is the rule, not the exception. 6 months to stand up, to acquire and provision and set up a server, and then get the software partner to actually install their software. And after about 6 months, they're ready to start innovating. We at SESME, through the great work of our partners like ThinkIQ, have been and Microsoft and soon to be AWS as well, have created a technology stack to do that in less than 5 minutes, to provision a smart manufacturing innovation platform that they can have access to for free for 6 months. So any member at SESME can log on, and if you're a member, an authenticated member, within 5 minutes you'll have your own instance of this smart manufacturing innovation platform, be collecting data from the plant floor and using one of probably 30 or 35 different manufacturing technology providers to do something intelligent with that data within 5 minutes. So that's the spirit of democratization, right? That's how we transform an industry and transform what used to be 6 months to start innovating back down to something like 6 minutes.
So in the previous panel, you were giving these comparisons between Apple and Microsoft in different domains, and some of the vendor lock or the standard lock that you would get, if you're an Apple person or a Windows person, right? What about Linux, right? What about the open source, side of this? There's an entirely different programming language, there's an operating system out there where anybody can go onto that and they can build very interesting artisanal applications. But businesses have been built out of open source. Red Hat is that example. And either Rob or John, either you want to take a run at this, but what I get excited about when I have these conversations with the SESME organization is very discreetly the profile tool. I come from Alcoa, and I was with SESME before SESME was SESME. One of the original founders. And my pain as a manufacturer is I did everything from mining to finishing products to building F-150s, and that was literally hundreds of different discrete factories around the world, thousands of discrete machines, and each one of the operating systems were slightly different. So to be able to get visualization across all of our operations, to ask interesting questions, and I think the previous speaker said there could be thousands of different hypotheses, just to get the data together, to get the visualization to start, we were paralyzed. And each time it was a call to an individual vendor. That individual vendor came with a big price tag. But he would create a solution, and then the factory downstream would have a different solution. Now I still didn't have my visualization. So at the beginning of smart manufacturing, what got me inspired was the idea that we were going to find a common denominator set of tools, and then from that common denominator set of tools, we would start to be able to quickly replicate that on both new equipment and legacy equipment. And when I say legacy equipment, I'm talking about an 80-year-old forge, that is 6 stories high, right? Hard to censor these things up. So Rob, John, tell us a little bit about the journey to build the profile tool. What is it, and what makes it so unique?
You want to start with the profile?
Yeah, I'd be happy to. So today, and by the way, when we talk about plumbing or infrastructure, it's never sexy, it's never fun. Nobody wants to pay for plumbing because it's infrastructure, right? But it's so vital and it's so key to solving the problems that we've identified here over the last couple of days at GMIS, right? If we're going to accelerate the democratization of smart manufacturing, if we're going to create a more competitive manufacturing environment, we have to dramatically reduce the cost and complexity of how to solve that problem, how to have the answer for the thousands of different questions that anybody's going to ask, whether they know it today or not. So that begins with this notion that today, in a classic like Industry 3.0 environment, I've selected a great platform. Might be Microsoft Azure's AI machine learning environment. It might be PTC's ThingWorks product, or Siemens' MindSphere product, or GE's Predix platform, or Rockwell's FactoryTalk platform, or ThinkIQ's awesome platform. But no matter who I select as a platform, if I have to connect to a robot or your ancient
Forge.
or a paper converting machine at Procter & Gamble, you have to sit down and build from scratch an information model. You know the old adage that it takes 80% of the time in any project to build the infrastructure so that you can spend 20% of your time creating value? Well, that's where that 80% of that time is, building an information model, regardless of the fact that 30,000 people in this country over the last 10 years have built an information model for a paper converting machine. It's a proprietary piece in someone's Excel spreadsheet or in someone's head, some subject matter expert's head, and I have to pay for it every single time, no matter who I am, in every single platform, right? That's not acceptable. 20 years ago, the IT community figured out that plug and play is a thing, that if I plug in a keyboard or a mouse or a printer or a screen, somebody ought to recognize that printer, at least as a printer, and some core functionality, and it just works, right? That's the idea that we're pursuing at SESME, and that's the tool set that we funded and created, and this year, for the first time, brought to the marketplace, the idea that we can crowdsource the creation of these really important plug-and-play information models for any kind of equipment, and then extend it. If you want to differentiate yourself, take that core and extend it. Take that core and build something even better, and put it back in the marketplace so that the next person can benefit from it. And if you want to charge for it, go for it. But the idea is that this is a self-perpetuating flywheel, and that we can borrow from the IT plug-and-play community for the first time in the OT world and propagate some of these great new patterns, some of these new ways to collaborate and really drive the industry forward.
So I want to come back to that in a second. The marketplace is new. That was recently released about 2-3 weeks back. That's live. You can go on there if you're a manufacturer, if you're interested in downloading one of these applications. It's a living bookshelf. It'll continuously be populated. But then I also want to come back about how you download this and how you actually get your hands on. But first, Rob, your team was fundamental in building the profiling tool itself. Right. Tell us about that architecture.
Yeah, I think so ThinkIQ, we are very closely partnered with SESME, and SESME's SMIP that's available, Smart Manufacturing Innovation Platform, is actually us driving that. And when we look back at the start of ThinkIQ 6-7 years ago, in part it was to rethink the problems of the classic legacy on-prem lock-in kind of model, right? And at the foundation of it are two things. Number one, it's cloud-based. So, kind of saying OT should just be cloud-based like everything else these days. How do we figure that out? And then number two, though, this idea of the model, right? And an information model-based assembly of Industry 4.0 and smart manufacturing technologies. What does that mean? Well, one key concept in it, for example, if we kind of think about the legacy alliterative of man-machine material kind of paradigm, right? Is so much of what we have done in OT is connect to equipment, right? We think about all the equipment. But last time I checked, people don't pay Procter & Gamble for the equipment used to make the toilet paper. I'm pretty sure they pay for the toilet paper, right? And changing the whole axis around how do we produce things people want, and really changing all the information flow to think about that, not the equipment. And that's an important piece of this puzzle, I think, because it starts making you realize, well, that's really what I'm trying to get to. And if that's really the most important thing, and I'm differentiating as a manufacturer, I'm making stuff, I actually want to remove all that noise to be the best at managing how I make it, right? And is it really that unique that I wrote a connector to talk to this forge? That's not where I really create value anyway. So I think there's a philosophical aspect of it, of getting us all back to what is it we do as an industry. We make stuff. We don't want to manage the machines that make it as much as what we do is really making the things. And so the whole information model concept that's baked into our platform, that's part of why we collaborated with Sesame, and Sesame chose us to be the power of it, is because that modeling framework is built around this concept of creating repeatable, templatized models, even within our platform, and it lends itself very well to this framework, right, of profiles and apps that can be in a marketplace. And the apps are important. If the data you're going to use in the app is different each time, well, then you can get stuck in the, especially with AI and ML, most people when they're working with, big data, they spend 80% of their time data wrangling, right, is the term. If you can start understanding these information models, the ability to have apps that plug and play and create value, just kind of like what you guys are doing with design, right? There's an algorithm around cooling channels, right?
Absolutely.
Well, how do I reuse that? Those things all come together to actually enable concepts of information models and apps that can be useful right out of the box without this 80% of the work that John mentioned. So that there's a philosophical part to it, and then there's a technical, instantiation of the concept that we've worked very hard to bring to market.
That's excellent. And Lin Han, so that we're talking mostly about the manufacturing floor and the process. You're with the end customer, with the engineer, and trying to open up that democratization. Tell us a little bit about that experience, because I know part of your title is education and outreach. So you're sitting with both the students and the people that are working within these organizations to look at how to get these dare I say, freemium tools into their hands to rethink what they're doing with their CAD products already.
Yeah, so we really want to radically democratize engineering. And if you look at it, we have a platform for you to build your own applications, and these are use case specific applications, right? So if you want a capillary channel, you have an app for that. If you want a rocket engine, you have an app for that. So we have a platform for you to do that, but we need to upskill someone, right? So we lie on the crossroads between software development as well as engineering, right? Be it bioengineering, aerospace, or mechanical engineering. And education is key, because without people who come on board this platform to build app, our marketplace concept wouldn't work. There will be no apps that will create value for our clients in the industry, right? So what my team and I do, across the world, be it in the UAE, be it in Europe, in Germany, be it in the US, is go to education institutions as well as research faculty and, ask them, what do you want to solve? What engineering challenges are you trying to address? And we work together. We upskill them to become algorithmic engineers and really radically accelerate the innovation. Yeah. So on the platform, we have content, video content for different levels of algorithmic engineering. Currently, we have 3, where we really upskill mechanical, bio, aerospace engineers to think with a software paradigm, right? Because just like how you want to build a website today and you never really have to write a line of your own code, next time if you want to do like cooling channel example, if you want to make a cooling channel, just drag and drop, copy and paste the code as well.
So this is like low code engineering?
It can be as low code as you want. It can be as high code as you need it to be. Yeah. So there's some really like dark magic that is going on behind the scenes, and we are actually incorporating simulations capability as we speak. Yeah.
That's fascinating, right? Because there remains that man-in-the-loop element with everything that we're talking about right now. And I'll go back to the previous panel. I think somebody had mentioned an example of a titanium, manufacturer here in Western Pennsylvania. If they've been around for 30 years, let's say they have, 5 different unique processing areas. They're doing some cutting, they're doing some forming. They hear about the platform. Right? They hear that Sesame has a platform, it's out there, it's open source, I can get going in a matter of minutes to hours. What does that journey look like? So you said there's a marketplace, but how do they engage with the institute itself in start?
Well, one of the sort of 6 key tenets of being a member at SESME is that you have access to some of the world's brightest smart manufacturing ecosystem, right? So while that can't scale forever, as a member at SESME, one of the great privileges we have is playing a matchmaker between the implementers that are kind of equipped and knowledgeable around these contemporary smart manufacturing ideas and are sort of all in on the idea of democratization, and the small manufacturer that is trying to get started on their journey and looks to transform their operation in some way, improve some part of their operation. So the brokering of those connections is a key part of what we can do. We have 30 hours of training on these key technologies, on these key capabilities. That's there for free for our members to sort of upskill their people, their citizen technologists on these ideas. Because the whole idea is that small manufacturer may not have any engineers on staff. They probably don't have any IT people on staff. And so how can you some good salesperson that can sell ice to an Eskimo might sell you on a great IoT solution, but can that manufacturer sustain it after the Eskimo salesperson goes back home, right? Yeah. And so it's so important from our perspective to align these capabilities with what the average manufacturer, small, mid-sized manufacturer can actually sustain. And so back to democratization, back to simplification. There is an upskilling piece, which is part of what we provide. There is the actual technology, and then there's the experts and the ecosystem that can come alongside that small manufacturer and help, because nobody is an island. This is truly an ecosystem play, and as we raise the tide, we believe that all the boats can float higher.
Yeah, that's fantastic. And it's something I've followed for years and of course worked with the team. And when you see it implemented and you see people adopting it, the eyes light up, right? Because you took all the mystery out of it, right? And there's a how-to guide about Digital Transformation 101. Before you have to call ABB and call Phonic and everybody else, to come rushing in, you can start from a near peer position by going through that first basic step.
So if I can just tell you a bit of a story. Yeah. Industry 3.0, here's the analysis that we did. For every $1 of a software solution that some great technology provider wants to sell to a manufacturer, there's $5 or $6 that'll be spent in seeing that $1 of license deployed. So if there's a $10,000 license, it's going to cost $50,000 to $60,000 more dollars to implement it and to actually see it become something that creates value. So $100,000 software license is going to become a $500,000 implementation, right? That doesn't scale. Conversely, we've got a small manufacturer in Medina, Ohio, 22 employees. What we were able to help them do is understand with a simple Raspberry Pi, industrialized Raspberry Pi edge device in their plant and a wireless network, 20 low-cost sensors, they can now, with literally several $100s worth of investment, they can now see that temperature sensor in their Excel spreadsheet, and that's all they have to worry about, right? So they figured out that if they move that on their auger that's moving some chemical compound, if they move that temperature sensor from the bottom of the auger to the top, that they get a much more consistent process. They can control the process much more tightly and have a much higher quality and a consistent outcome, right? And that was with a couple of $100s worth of investment. So that's the kind of story we want to tell all over the world, right? Instead of spending $100,000, you can start with a couple of $1,000s, and now you've got your citizen technologist, none of whom, they don't have an IT person or an engineer. It's the plant manager of this 22-person shop that's their citizen technologist. He's become a geek. He loves playing with the sensors and trying to figure out what that means to his product and to his outcome. And that to me, that's what kind of gets me up every morning.
And look, I'm an evangelist. I'm here to tell you it works. And that really gives me hope for being able to bridge this digital divide. So I've been given the 5-minute warning. And I want to bring it back to what I think is the burning platform now for digitization for small to mid-sized businesses, and that is carbon accounting the need to digitize. You're going to have a lot flowing down from the Fortune 1000s saying, can you produce X report, Y report? So just quickly, from each of your perspectives, how are you solving for that? How are you getting ready your partners or your customers to be able to answer that energy decarbonization question that's coming at us real fast?
Yeah. So kind of going back to the concept of the model, right, that drives these things in information models, and thinking about the stuff you're making and then the stuff that's used to make it, both the raw incoming materials or ingredients you use to make the final product and where they came from, and the sourcing of that, as well as what is my transformation costing me to get that done. The same thing as we do in our platform to understand how you make the stuff, I can then keep decorating, if you will, additional attributes and information on top of the model. So I can now either have a sensor that is measuring the power draw for the piece of equipment, or if I know the nameplate on the motor, I can actually infer quite accurately that when the motor is running, here's what it's pulling. And I can also understand local power, what's going on right now. And without having to do a lot of instrumentation, you can actually infer pretty accurately what's happening in terms of your energy consumption. Or I can attach greenhouse gas, landed cost, right? So building on top of that, understanding how we make things and how they move through the process, we're enabling with profiles and with the platform the ability for folks to understand all that and report it quite accurately once you've got a good model without having to do a separate project for reporting this. And you kind of mentioned before, how do you get this close to zero, right? 4.0, zero cost to do it, so I can be zero, right? Carbon neutral, et cetera. And there's another aspect to it, which is zero skill, right? So if you don't have to have specialized knowledge and skills of how to do carbon reporting or energy consumption, but it can be a byproduct of what you do every day, which is make stuff, we believe that'll make it a lot easier for all companies to start understanding this and managing it better and reporting if required, but hopefully the benefits are more self-evident.
So I love the 3 zeros, right? We can chase this. John, your thoughts?
So the old adage, you can't manage what you can't measure, is still true. And the cool thing from our perspective is that the same infrastructure that you want to implement in a low cost, low complexity way to solve your manufacturing constraints, measure your inventory, and refine your manufacturing process or improve your quality. It's the same infrastructure that you can use to decorate it, as you said, Rob, with energy management, with greenhouse gas emissions monitoring and reporting, whether you're measuring or inferring. And so the idea that you would have to buy yet another solution, another custom system to measure and then manage your greenhouse gas emissions, just it is indicative of the sort of stovepipe silos and vendor lock-in that Industry 3.0 is all about. So we're excited to be able to say to our manufacturing membership, you know what, we need to think about this problem in ways that enable every imaginable manufacturing capability and analytic and predictive modeling and constraint management and quality measurement and management. All of these domains and all of these capabilities need to reside around the same core infrastructure, and that's from our perspective is what's so key.
And the proof is in the demonstration. So back in the spring, you successfully demonstrated with the German partners at Platform Industry using the profiles, the ability to track carbon, off 3 distinct manufacturing processes. 1 in North Carolina, 2 in Germany. It was live at Hanover to the 4th decimal point.
Yeah.
So, Leonardo, your thoughts? Because I know you guys think a lot about the sustainability and energy footprint.
Yeah, so I think where we come in really complements what you guys are doing. So instead of standardization of process and tracking, we do actually sustainability by design. And what we mean by that is we focus on high impact objects like heat exchangers, for example. Do you know that 40% of carbon emission is contributed by heating and cooling energy consumption? That's a lot. And if you can imagine if our residential heat pumps or heat exchangers can be 10 times more efficient, what wonderful carbon reduction can we bring? And that's exactly our mission that we're working with the UAE government and Strata on, So how do we make residential air conditioning 10 times more efficient so we can use the energy that we produce, which is limited, more efficiently? And second way is by trading digitally. And this is where I really think the Sesame platform could also, play a part in. Every day in our office, we design algorithms and applications to be shipped digitally to maybe our partners in China, our partners in Europe, and in the afternoon, they would have already a product in their hands, printed, ready to be used, right? So this whole notion of design global and produce local is really going to cut down a lot of carbon emission that would otherwise be incurred through transportation.
You're in the business of shipping bits, not atoms.
Exactly.
Right? I love it.
Yeah, exactly.
Gentlemen, thank you. I appreciate the time. Thank you, everybody.
Thank you.